Welcome to episode 13 of the Norton Nemesis 1500cc V8 rebuild, and in this episode I'm going to be replacing the cylinder heads, having a look at the induction system and having a look at the rear exhaust manifold. With the bottom end fully assembled, it's time to get the cylinder heads on, so the first thing I do is fit all the O-rings around the water passage galleries. I first put a bit of silicone sealant in the bottom of the groove to ensure I get a good seal, then place in the O-rings. I sometimes use a small artist paintbrush to smooth out the silicone sealer to make it uniformly around the surface, then the O-ring snaps in place nicely. This engine doesn't run conventional head gaskets. It has O-rings around the water passages and the oil passages, and phosphor-bronze rings around the cylinder liners. Each of the phosphor-bronze rings has been machined so it protrudes 0.02 of an inch above the cylinder liner. I covered this in the previous episode. This is to ensure a good seal when the head's bolted down tight. With the phosphor-bronze rings fitted, I do a final check that all the O-rings are in the right place, especially the oil one at the end. Then I put a thin smear of silicone gasket sealer around the surfaces and drop on the cylinder head. It drops down nicely onto two raised dowels. I then fit all the cap head bolts that hold the cylinder head onto the block, doing them up tight with my hand with an Allen key first. We'll be torquing these down later on. The cylinder head bolts need to be really tight, and I have trouble using my torque wrench and holding the engine still at the same time, so I had to use my knee. It was quite hard, but I had to put a lot of force on the torque wrench to do them up. With the rear cylinder head bolts tightened, I put in the two screws at the side. I now repeat the process for the front cylinder head. With both cylinder heads torqued down, I now need to set the rear pistons on the outside to a top dead centre using my DTI, so I can install the camshafts. I turn the crankshaft backwards and forwards till I get the highest reading on the DTI. This indicates top dead centre. After a few minutes of turning the crankshaft backwards and forwards, I finally set the pistons at top dead centre and can remove the dial gauge. We're now all set to put in the camshafts, so first of all I put some engine assembly lubrication on the bearings. When I remove the camshafts, I use some blue paint to mark the tooth that lines up with the side of the engine, and also whether it's an exhaust cam or an inlet cam, to ensure that I get them back in the same place when I rebuild the engine. I carefully lower in the first camshaft, engaging the intermediate drive gear and ensuring that the blue tooth is in flush with the top of the cylinder head, like this. I then repeat the process with the second camshaft. I then replace all the cam caps and screws and do them up finger tight. Then gradually using an Allen key pull the camshafts down into their bearings. I covered in detail how the camshafts are fitted in episode 12 during the trial assembly. I thought I could hear some noise in the kitchen, but I'm sure Tracy said she was going shopping today. I'll go and have a quick check just to see. Yep, she's not there, but she did say there might be some cakes in the tin, so I'll have a quick look. There is one cupcake left, just perfect, so I'll take that out and that'd be so nice. Back in the garage, feeling fully refreshed, I've now got to finish tightening up the rear cylinder head camshaft caps. There's so many of them, but they've got to be done so carefully, a bit at a time, to gently force the camshaft down, compressing the valve springs. But we get there in the end. With all the camshaft caps tightened on the rear bank, I can now set the pistons to top dead centre on the front bank, the two outside pistons that is. Then I repeat the process from the rear, fitting the two camshafts, all the caps and all the screws. I'm now ready to see if the engine will turn over. Before I do, I've got a few things to do first. I very carefully turn it over by hand with a spanner on the end of the crankshaft for 2 revolutions to make sure the valves don't hit anything, which they didn't, which is really good. Then I need to block off the oil pressure gauge feed pipe with a ball bearing by putting a threaded sleeve onto the thread, dropping in a ball, and then putting in a screw to lock it tight against the taper. This will prevent any oil from leaking. And the last thing I need to do is to replace both the front engine side covers, put in some oil, and we can crank it over on the battery for the very first time. I connect up the earth terminal and I'm really pleased to see the camshaft spinning around nicely, and after a few seconds oil flooding up through the bearings, which is a really good sign. I'm also really pleased how long it went on a single charge, because this is a relatively small battery. I look outside and it's absolutely pouring down with rain again, and there's a squirrel raiding the bird food. I guess he's hungry as well. Back in the garage, and with the engine turning over nicely, I now need to concentrate on making an oil separator and breather for the rear cylinder head bank. And to do this, I've got a piece of aluminium on my lathe, machining up into a square block. I like using my lathe machining square things. It makes it quite interesting, holding things in forward draw chuck and facing them off. With the basic shape machined, I put the block of aluminium in my miller machine to mill out 2 cavities. This will separate the ore from the air. I'm making a simple single baffle oil separator so that the oil in the air comes out the engine, flows over the high wall in the centre. Hopefully the oil drains back and the air continues out of the hole at the end. Well, that's the idea anyway. This is commonly used on many engines. With the main body finished, I drill and tap 4 holes in the corners to secure a lid. I now use a bit of 320 grade Abranet cloth to clean up all the machining marks and make it all nice and smooth. With all the components finished, I can now start assembling the cam covers, ready to put them on the engine. I first fit a cover plate to block up a redundant coolant outlet port. Then I fit the breather in the centre, which is the oil separation breather in one. That bolts in place with 2 screws. Then on the right hand side, I fit the coolant outlet pipe that I've made. I've just noticed the breather's pointing the wrong way, so I turn that round before I screw it down to the crown cover. Underneath is a splash guard to prevent oil being splashed off the camshaft itself straight out of the hole. So now the cam cover is ready to fit to the engine. So first of all, I fit new O-rings around the spark plug holes. Then I use a bit of ultra grey gasket sealer on the end caps and put those in the slots where the camshafts go. These snap into place nicely with a bit of a push. The cam cover bolts down directly onto the cylinder head, so I use a bit of silicone sealer to make sure it doesn't leak. I carefully lower the cam cover down onto the engine, ensuring that the coolant pipe comes up through the hole. Then replace all the screws and tighten. With all the screws tightened, I slide down the coolant outlet port onto the crown cover and do up the screws. I then repeat the process to fit the front cam cover. With the main part of the engine fully assembled, I now need to concentrate on the induction system. The standard system comprises of these 2 tubes that slide into bores in the cylinder head, and when you rotate them backwards and forwards, they open up the inlet ports like a throttle butterfly. I've had the tubes hard anodised to help them rotate, but they still squeak quite badly. But I guess when the fuel's running through it, I give it some sort of lubrication. I think this system is designed for full throttle operation where it'll work very well, but part throttle, I'm not so sure. The throttle tubes have no seals between each individual cylinder, so there will be air leaks which will cause erratic running at low speed, I'm sure. So what I'm going to do is make an alternative system just in case, so I can fit some CBR 600 throttle bodies. I place the 2 sets of throttle bodies in the V of the engine, and they look just perfect. Just need to make an aluminium inlet manifold to fit them, to line up with the ports on the engine. To do this, I found some bits of tube and some flat plate, made up a flat plate that bolts onto the engine. You can rest the tubes on the flat plate, weld them in place, then slide the new throttle bodies on and do up the clips. To get the port spacing to line up, I had to machine angles on some of the tubes. With the last tube machine, I just need to slide the throttle bodies on to check the spacing, then I can weld it all up together. With the inlet manifolds finished, I think I'll remove them from the engine and unpart them for the future, just in case they're needed, but at least they're all made ready. The next thing I need to look at is the rear exhaust manifold. I just remembered up behind my shed, I think I've got an old ST1100 manifold system, which is stainless steel pipe, with some nice bends in that might be useful to use. So the first thing I do is mount the old exhaust system onto the back of the engine, bolt it up, and make a little stop underneath so I can see where it needs to rest for the new system. It's like a gauge that rests underneath the exhaust, so I can make it in the right place. Then I make up a new one-piece flange from mild steel plate. After a lot of cutting and trimming, the stainless steel tubes fit just perfect. I'm able to marry them up together to make a 4-into-1 manifold. With all the sections of pipe welded together, I need to true up the flange where it bolts onto the engine. I use my file gripped in the vise and move the manifold backwards and forwards, pushing down hard, holding it square and flat until I get a nice smooth surface. After about 30 minutes of rubbing backwards and forwards, the flange is perfectly flat, so I'm really pleased with that. I take it out in the garden, give it a nice coat of satin black heat-proof paint and bake it off in my barbecue. I bake the paint at 150 degrees C for about half an hour, and it's really hard, so that's just nice. So now I can come back in the garage, fit a new gasket to the back of the engine, and offer up the manifold. It's quite fiddly getting the nuts underneath. These are M5 stainless steel nuts. You can only just about reach them with your fingers at full stretch, and you have to use a little screwdriver to actually turn them in before I can get the spanner on to tighten them up tightly. With all the screws and nuts tightened, I think the manifold looks a lot better than the old one did. Hopefully it should work quite nicely. So now I can fit the front manifold. This is the original one, and it's actually quite nicely made. With the front exhaust manifold bolted back onto the engine tight, the next thing I'm going to do is refit the trigger wheel to the crankshaft that runs the ignition system. I'd left this off because I wanted to test it on the bench first with all the components connected up to see if it actually works with the ECU. To test the system, I mounted the trigger wheel into my drill, put the Hall sensor in a little vise and offered it up to the edge of the trigger wheel, so when it span, it was creating the crankshaft running. Then with all everything connected up and the battery and the ECU all connected with all the wires, I could look at the injection system and it's actually clicking nicely, which is a really good sign. With all the injectors clicking away nicely, I glance over at the spark plugs and they're all sparking as well, which is really nice to see, all 8 spark plugs with big fat blue sparks. So now I can remove the right hand engine cover and fit the trigger wheel to the crankshaft. The trigger wheel slides onto a raised dowel and held in place with two screws. The crankshaft position sensor then slides into a hole in the front of the engine and held in place with a screw. So now the last thing to do is to replace the right hand cover and do up all the screws. Well, thanks for watching. I hope you enjoyed it, and I'll see you all soon in the next video where hopefully I'll be firing up for the first time on the bench.